This is the, I think, eighth lecture. In this lecture, we are going to discuss about the electric field intensity due to the uniform charged ring at their axis. We are going to find out the electric field at this point and the axis of uh, the center joining these axes of the circle and axis of the ring basically, and this ring has a uniform charge distribution. Let's suppose positive charge distribution, and I take the uniform charge distribution. I define the lambda is equal to dq by dl, basically dq by dl, let's suppose, and dq is nothing but the small element here, and dq the length, it is having the dl, and due to the this dl element dq charge distribution, we first we find out the electric field at this position. Let's suppose the ring has the radius capital R, and we want to find out the electric field at this point. It is in this direction, yes, and this is electric field is nothing but I take at E del dE, yes, and then similarly let's suppose I have to vary, yes, I have to vary the dq from this position. Then basically here also you have some dq element, yes. According to this dq element, you will get some like of electric field dE here also, and if you resolve both of these, you will get let's suppose I take the theta here, and I take the this is the z distance from the center to the p point that we are finding out. It is perpendicular, yeah, on the axis we are going to find out, and then if this is theta and then this is also theta, then this component become dE cos theta, and again if you and this component become dE sin theta, yes. And similarly, and if you resolve this, you will get the double of it, yes, the integrating, you will get the adding of these vectors basically, cos theta, and the dE this is, sorry, the sin theta, and this is nothing but the again dE sin theta, yes. They are equal and opposite direction, yes. This is the vector, nothing but the dE vector, and this is the sine vector, d sin vector. They are equal and magnitude and opposite in direction. Then we simply, they will cancel out, and according to here the dq element, you will get if you integrate to the dq element, can you imagine, you are probably you will get some kind of cone, yes. You will get the dq here also, dq dE, sorry, dE here also, dE here also, yes. Then all these d sin theta will make some kind of the circle. Okay, let me try this. This is the dE sin theta, look like a circle in the below, yeah, and all the dE sin theta, you will get dE sin theta in the equal and opposite direction. All the elements you will get, I think you are getting, and then these all dE sin theta will cancel out, and then you are getting, they will cancel out basically, and then only the dE cos theta will remain, yes. And basically these all are adding up, then it is nothing but the E is total electric field in the, let's suppose I take this direction, the above direction is Z, and then the electric field is nothing but integration of the dE cos theta. Basically I have taken the 2 because then I take the 2 element, because there are infinite number dE, then you have to integrate it basically, and then I will put the value the dq dE, sorry, dE is nothing but integration 1 by 4 pi epsilon naught D is due to the dq element. Yes, basically dq element, and the distance, you have to know the distance from this the point where you are finding out, and this charge, this is nothing but this is the capital R Z plus R square. Yes, then this is nothing but then it should be square, then under root will remain, will remove, and then I think I will should write the completely, and then cos theta also, do not forget the cos theta. Then in the next slide you will get, if you put all these values, then just remember that this sin theta, all sin theta component will cancel out, then the e vector in the z direction, okay, remember it, and 1 by 4 pi epsilon naught will come out, and then you are integrating dq, because let me write first, dq is nothing but r square plus z square, the power, I think power, it is 1 only, because you have to square and then under root, and then cos theta value, if we go back, the cos theta, pick the cos theta, and just pick the value cos theta from here, the cos theta, I think, then the cos theta is base is z according to theta, and then the hypotenuse is the z square plus r square, okay, and then just put the value here, then after putting the value z by r square plus z square the under root 1 by 2 power, then if you put the, let me try, 1 by 4 pi epsilon naught, and r square is constant, z is also a constant distance on which we are finding out, then it is simply these denominator come out to be, and z also, then I think then you will getting z by r square plus z square the power 3 by 2, and if we integrate, and basically dq is nothing but I have defined the lambda is equal to dq by dl, then it become dq become lambda into dl, and lambda is also constant, then your answer is coming out to be 3 by 2, and then lambda come out to be, then integrating dl is nothing but dl element is on the ring, yes, the small element on the ring, if you integrate it you will get the whole circumference, yes, because we are considering the ring, then the whole circumference of the, if you have the r radius, then the circumference, you have a periphery, perimeter, you will get 2 pi r, yes, and then the ultimate result you are getting z 4 by 4 pi epsilon naught 2 lambda r, and below you are getting z plus r, and just look at the it carefully, look at carefully, you are getting it depend upon the z, yes, the z is directly proportional to, and remember that it is electric field, and I have taken the in the above direction, it is z cap only, then remember it z, when the z is on the 0, z become the 0, then we are interested to find out the at the center, yes, when the z is 0, then the all electric field will cancel out, it means simply you can also imagine that let's suppose this is the dq element, due to the dq element you have the electric field in this direction, yes, and due to the opposite in the exactly opposite dq element, again you have the electric field direction, are you getting in the similar way you have dq direction here, and all vector will cancel out and then give the 0 result, yes, then the electric field at the center, you can write the point, electric field at the center is 0, and just electric field at the center is 0, and at the above you will get the, okay.